Is this working? Hello? Hey guys, welcome to video 2.3, and in this video we're going to be learning about scientific notation, standard notation, and how to round sig figs or sig digs. You know, you can call them whichever you want, it doesn't matter. So standard notation and scientific notation are terms you should have learned prior to this class, but if you haven't, we will review it right now. So this is an example of a number in standard notation. Let me find my little marker here. Let's use green because I can. Okay, so this number right now is currently in what we call standard notation. Standard notation just means it's a number that is written regularly. Standard, right? So normally numbers we just write out and we leave them on the page the way they look, but sometimes in chemistry specifically we deal with really big numbers, or we can deal with really small numbers. We really don't deal with numbers like 10, 12, 100, or 1,000. We deal with huge, or we deal with really small. So instead of writing out huge numbers and writing out all the zeros at the end of a huge number, we use a way to shorten it called scientific notation. Okay, so scientific notation is a way to shorten really big or really small numbers. And so the way we do that is we are going to take wherever the decimal is located currently, which in this number, it's obviously located at the end of the number right there, and we're going to move that decimal place till there's only one digit to the left of the decimal. That's something you want to write down. Scientific notation has to have only one digit to the left of the decimal. So that would mean our decimal would need to be right there, okay? Right next, in between the 1 and the 3. So we have one digit to the left of the decimal. So if we write our number like this, 1.37, well, that's a completely different number than 137 million. So we need this 1.37 to be the same value as 137 million. So what we're going to do is we're going to multiply that number times 10, and we're going to put a little exponent value here. That exponent value will represent how many times we had to move the decimal. So we're moving the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. So we're going to put 8 as our exponent. So 1.37 times 10 to the 8th is actually the same thing as 137 million. It's just a shorter term to type out. A lot of times our calculators will give us numbers in scientific notation, but they look a little bit different. They look like this. So in your calculator, you're going to see this E, and this E just stands for times 10. And then the 8 looks like a regular number 8, but it's not a regular number 8. It's actually the exponent 8. So in your calculator, sometimes you're going to see it looking like this. But when we write it out, I want to see this format. So let's practice with this value, 347,000. If we want to write it into scientific notation, we need to have only one digit to the left of the decimal. So I'm going to write 3.47. times 10, and then I have to ask myself, how many times am I going to be moving that decimal? Well, move it once, 2, 3, 4, 5 times. So I put a 5 here. We are always going to use a positive value right here when we're dealing with really big numbers. That makes sense, right? In order for 3.47 to equal 347,000, in order for those two numbers to equal each other, we need this value to be much bigger than it is. So we're going to multiply it by a positive exponent so that it becomes a bigger number, okay? So here's some practice ones. Go ahead and pause the video right now. Write these two example problems on your page, and then once you've found the answer, click play so you can see the answers and see if you got them right. So pause, don't just keep watching. Okay, so the first one, this is our answer, 9.02. See how my decimal, I only have one number to the left of the decimal, so 9.02. And then how many times did I move the decimal? 1, 2, 3, 4, 5, 6, 7, 8 times, so I have 8 in my exponent. The second value, I only have one digit to the left of my decimal here, 6.14, and then I move the decimal 1, 2, 3, 4 places, so 4 is my exponent. All right, so why does a negative exponent give us a smaller number? Because we've only looked so far at ones with positive exponents, right? where it's a positive number here. Well, look at what that means. 10 to the 4 means that we're multiplying 10 4 times, which basically means 10,000. 10 to the 3 means we're only multiplying 3 tens, so we're 1,000. Multiplying 10 to the 2 means we're multiplying 2 tens, so on and so forth. So as you can see, this number gets much smaller when our exponent gets smaller. So we eventually will be seeing numbers like this, okay, 0.1. When we see a decimal number, we can write it in scientific notation by moving the decimal to the other direction. We still have one digit to the left of the decimal, but here I move the decimal just one place to the opposite direction, so I have the opposite sign. The negative one means that this current value is bigger than what my standard value is, so I have to multiply it by a negative number to bring it back down to its original value. And here it shows you as it increases what happens when we use a bigger negative exponent. Okay, so now we're going to do the opposite. So we're still writing into scientific notation. We're just using decimals. So go ahead and pause this video. Try these 3 problems on your own, and when you're done with them, click play, and you can see your answer. Okay, the first one is 8.82 times 10 to the negative 4. Notice we only have one number to the left of the decimal, and I moved the decimal 1, 2, 3, 4 places, and I stopped there. We're not going all the way to the end. We only want one number to the left of the decimal, so we have to stop there. So I put negative 4 because this number, 8.82, is much bigger than my value. And so in order for it to equal this number, in order for these two to equal each other, I have to be multiplying it by a negative value. Okay, so smaller numbers, decimals, have negatives. Bigger numbers have positives. Here are your answers for the other two, 5.9 times 10 to the negative 7 and 4 times 10 to the negative 5. All right, now we're going to go backwards. I'm going to give you a value that has scientific notation. I want you to convert it to standard. So remember how the positive value means that this value right now, 5.02, is smaller than what it's supposed to be. It's supposed to be a much bigger number. So that means I have to move my decimal 5 places the other direction. So I'm going to move it once, twice, 3, 4, 5 times, and that's my decimal. So I have 3 spaces for 3 zeros to put. So 502,000 is my answer. Now I have a negative exponent. I'm going to be moving my decimal a different direction. So my decimal was here. I'm going to move it 1, 2, 3, 4, 5, 6. Here's my decimal. So I have 1, 2, 3, 4, 5 zeros there. And then we always put a 0 in front of the decimal as well. Okay, go ahead and pause your video and try these 4 problems on your own, and then click play. Okay, so for this one, it's a positive value, so it's going to be a much bigger number. So here's my decimal. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Now here's my new decimal. So I have 1, 2, 3, 4, 5, 6, 7 zeros there. So there should be 7 zeros, and our decimal has been moved to the very end. This is a negative value, so we're moving our decimal to the opposite direction. Okay, so we have 804. Here's our current decimal. We're going to move it 1, 2, 3. Here's our new decimal. So we have 2 zeros after the decimal, and we always put a 0 in front of the decimal. This one we're going minus, so we're going to have a really small value again. Here's our current decimal. We're going to move it 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our decimal. We put a 0 in front, and then all the rest of these should be zeros. That's a total of 9 zeros. And our last one, it's a positive value, so we're going to move our decimal the other direction. 1, 2, 3, 4, 5, 6. Here's my new decimal. So it's 7 million is my final answer. All right, the last part of this video is rounding. I'm going to give you 3 values, and I want you to practice rounding them to different significant figures. Okay, so we're going to practice counting significant figures here. We want to have 3 sig figs in our number. This number currently has 4 sig figs, right? This last 0 doesn't count as a sig fig because there's not a decimal there. So I want 3 sig figs, which means I basically want this number, 105 or 10,500. Basically, that's the number I want, because here's my 3 sig figs. However, I have to round. So you need to look at the number next to, you need to look at the last number that you're taking off and see, do I need to round up or do I need to round down? Since that number is a 6, I really need to round this 5 upwards. So it's 106, or 10,600. This next problem, if I want to have only 3 sig figs, here's 1, 2, 3, which means I have to take these off, and the 0 at the front doesn't count because it's just a placeholder. So basically I want to write 0.529, but I have to ask myself, the number right before the 9, do I need to round it up or down? Well, 4 is less than 5, so I don't need to round the 9 up. I'll just leave it the way it is. Okay, so this value, when we're looking at scientific notation, these never count towards sig figs. So this current problem, I have 4 sig figs, but I only want 3, so I want to chop off the 4. The question is, can I leave it 4.12, or do I need to go up to 4.13? Well, 4 is less than 5, so I can leave it at 4.12, and then I still include my exponent even though it doesn't count as sig figs. Okay, so I want us to try this again, but now we're only going to round to 2 sig figs, so this might be a little bit more difficult. 2 sig figs means I need 2 numbers here, okay? This is a little bit tricky. I want to take off all of these numbers. Remember, the last number that you're taking off, you need to figure out, do you round up or do you round down? Well, if it's a 5, we're going to round up. So our answer is going to be 1, 1, those are my 2 sig figs, and then the rest of these are placeholders, okay? So 11,000 is my answer. For this problem, if I want to round to 2 sig figs, I want all the rest of these values gone, right? But since this last number that I'm taking off is a 9, I actually need to round this to 0.53. This one, if I only want 2 sig figs, I want to take off the 2 and the 4. The 2 is less than 5, so I can leave it at 4.1 times 10 to the negative 2. And that's it for this video. You guys can start your Check for Understanding quiz.